Hello, geometry students. It's day 8, and we are talking about something called cofunctions. So when we look at these first few, it's going to give us an example of what that actually means. Given the 3, 4, 5 right triangle, it's asking us for sine of A and cosine of B. So remember, sine we know is opposite over hypotenuse. So in my picture, 3 is opposite angle A. 5 would be the hypotenuse, so that would be 3 over 5. And then when we look at cosine, well, cosine, that's A over H. And so when I look at angle B, the adjacent side would be this. The hypotenuse stays the same. So that one comes out 3 over 5. All right, let's move on to the next one. Here we have another nice Pythagorean triple to work with. Angle A, sine is opposite over hypotenuse. So opposite hypotenuse would be 5 over 13. Now do the same thing for B. If here's B, we want cosine this time. So the adjacent side here would be the 5, and then over the hypotenuse of 13. You're probably starting to see what's going on here. So when we get to the bottom one, to our last Pythagorean triple in 8, 15, 17, sine of A, that should be 8 over 17, because there's our opposite over our hypotenuse. And so then cosine of B, without doing any work, probably know what it's going to be. That's our adjacent over hypotenuse, which in this case is also 8 over 17. So this first page is just giving you a quick example of what happens when you take the sine of one angle in a right triangle, one acute angle, and then the cosine of the other angle. So when we flip on over, let's kind of put all that together here. So what it's saying is in general, all right, well, in general, I'm going to call this A and call that B. In general, the sine of angle A should be equal to the cosine of angle B if A and B are the acute angles of a right triangle. So there's the first part. And then the other relationship that then happens with that is because the angles add up to 180, that means that A and B themselves, or I should say the measure of angle A plus the measure of angle B, those two together have to equal 90. And when we think about angles that add to 90, the vocab word that should come to mind, those are complementary angles. So when we say that we have cofunctions, it comes from that complementary piece of it. So sine and cosine are cofunctions because they are equivalent for complementary angles. With that being said, come on down here. When it says write each of the following in terms of its cofunction. Well, if we've given you cosine, then its cofunction would be sine. And you'd have to think, what is that angle going to be? Well, if I have a 40-degree angle here, what's the other angle up top? Well, this one should just be 90 minus 40 or 50. And now if you're ever thinking, well, how do I know if I'm doing it right? Grab your calculator, type in the cosine of 40. You are going to get a decimal, which is certainly fine, but then type in sine of 50 and you get the same decimal. So the cofunction of that complementary angle comes out equivalent. All right, so if I give you sine this time, then the cofunction is cosine and it's of the complementary angle. So 90 minus 70 would be equivalent to cosine of 20. Easy. Right? So you can draw the picture if it helps you see it, or you can simply just think, all right, find the cofunction. So in this case, it would be sine. And then I'm finding its complement by subtracting from 90. So 90 minus 52, that's going to be 38 degrees. Again, you can always confirm it on your calculator. All right, and then the last one, if we have sine of 81, that should be equivalent to cosine of 90 minus 81 or cosine of just plain old 9 degrees. All right. As for the last ones, if it leaves just an x there, we can still answer it. Cosine, then the cofunction would be plain old sine, and then it's 90 minus the angle. So it would just be stopped and left like that. So sine of 90 minus x, or you could write sine without the e. Same with the last one. If sine of x is equivalent to then cosine of 90 minus x. So this is just a more like general way how to write it. All right, so whatever x is, just insert that value and you're good to go. All right, you got one last little page to look at. So how do we apply this other than just saying, hey, cosine of 40 is equal to sine of 50? Well, if it tells you that sine of 5x minus 6 is equal to cosine of 9x minus 2, you then have to think to yourself, what's the relationship between those two expressions? The idea is that this and this are complementary, meaning that 5x minus 6 plus 9x minus 2 should be equal to 90. So you add the expressions and set it equal, whoops, to 90 degrees. That's what I'd want you to do. And then just simply solve. So here we can combine these. This will give us 14x. We can combine those. That'll give us minus 8. Right? And then if we add that 8 on over, we get 14x equals 98. Divide by 14 equals 7. The last little part, I want you to check your answer. Check and make sure that it makes sense. So we would have then sine of 5 times 7 minus 6 equals the cosine of 9 times 7 minus 2. All right, do some quick calculations. That's 35 minus 6. That's going to be 29 degrees. All right, 9 times 7, that's 63 minus 2. That should be 61. And then you can grab your calculator to make sure it's right. So sine of 29 degrees, that's 0.484. And then cosine of 61, that's also that 0.484. And of course, it kind of keeps going. But the idea is that we can check and make sure. Even a faster check, just 90 minus 29, does that come out to be the 61? Absolutely. So the nice thing is you don't have to wait and be told if you're right or not. You can just check and know for yourself. All right, you got one last one to try here. So same type of rule. If cosine of this equals sine of that, then these two, if I add them together, should be equal to 90 degrees. So let's try it out. If we take x squared plus 30 plus 11x equals 90. You know how to handle a question with x squared and a single x. We need to get it equal to 0 first, with then the goal to factor to be able to solve. So let's see, if we have x squared plus 11x, I'm going to move this 90 on over. So that'll give me minus 60 equals 0. This is a nice add, multiply. If you can't think of factors of 60, go into your y equals 60 divided by x, and then we can look at the table. I'm going to do that to show it here. So into my y equals, whatever's in there, get rid of it. 60 divided by x, and then go look in the table. So 1 times 60, I can zoom in a little bit here. 2 times 30, 3 times 20. So I am looking for that difference of 11. So 4 times 15, ooh, there we go right there. So 4 and 15 will do it. All right. So I'm going to go plus 15. Whoops, let me zoom back out. And then minus 4, and then solve. This would give me negative 15. That one's going to give us positive 4. Don't necessarily reject the negative. Plug it in and see. So when you go to do your little check here, we would have cosine of, if I put in negative 15 and square it plus 30, it's going to be a really big angle. And then this times negative 15, that's going to end up coming out negative. So yes, that one doesn't make any sense. We can ditch that answer. Right? As for the 4, then cosine of 4 squared plus 30, is that the same of sine times 11 times 4? Well, this would give me sine of 44 over here, 16 plus 30, that's going to give us 46. And 46 and 44, those absolutely add up to 90. I know it's going to check out. So my final answer there would just be the x equals 4. All right. Thanks for watching.